So moving on in trigonometry, we're going to pick up where we left off, and we had finished off with running our calculators, basically. Your calculators are programmed with the information for the decimal equivalents for different ratio or different angles in right angle triangles. So here are some questions for you to take a look at. These ones are, so that you can make sure that your calculator is working smoothly for you. These ones I've rounded to 4 decimal place, just as is the rule. Yeah, hopefully your calculator is working well. We're going to use that application when we solve for a side in a triangle using trigonometry. The other skill down here is solving for an angle. And so when we find the angle, we want to go to the nearest degree on this. So this one is about solving an angle. And these ones are the ones you have to use the inverse trig function or the second function button. Remember, some of you had IN or INV as that button that you're going to use in order to unlock what that angle measurement is. So your calculator will do the work for you. The angle here would be 9 degrees. Angle A would be 58 degrees. This theta down here, D, theta would be 72 degrees. And I did C last because C is honestly the most useful one for us moving forward in today's notes and class. And so when you use this, when you do this one, you actually have to put in the length of the two sides here. And so in that one, make sure that you can run your calculator and get that angle B is 42 degrees. So moving on in the next little bit here, we're going to be using the SOHCAHTOA, the sine, cos, and tan ratios in order to solve triangles. And so we're going to start by solving for sides in here, and we're going to use those trig ratios. So remember, the memory device was SOHCAHTOA. And what that stood for, or what that was representing, was that the sine of an angle is equal to the opposite over the hypotenuse. And the cosine of an angle is equal to the adjacent over the hypotenuse. And the tangent of an angle is equal to the opposite divided by the adjacent of the triangle. And so in these ones, we're going to kind of have this strategy, and these are the formulas that we're going to employ as we work through the notes here. So the first thing we're going to do is label the triangle. The hypotenuse was always the easiest one to label, but we'll label the other sides that we're given or being asked about as well. From that information, we're going to be able to choose a trig ratio. So we've got these ratios over here listed, so we can kind of take a look and see which one is relevant for the triangle that we're working on. We're going to write that equation down, and then we're going to sub in the specifics about the triangle. We're then going to solve, and we're going to talk about how there's two different ways to solve. You could talk about cross multiplying, and we'll just work through these because it's easier probably to show you than tell you on that. So in labeling up A, 55 is my reference angle or my target angle or the angle that I care about. Side A would be opposite to that. 25 would be my hypotenuse. And so when I can see that I have a triangle here labeled with opposite and hypotenuse, that's going to allow me to choose the right formula over there. So I'm going to use the sine theta formula because that's the one that fits the reality that I have for this triangle. And then going to sub in what I know. So it's not just sine of an angle, it's sine of 55 would equal A over 25.0. In solving for A, I could think of it as clearing the denominator, or I could cross multiply. I would have that A equals sine 55 times 25. Essentially what I could do to get A by itself is multiply both sides of my equation by 25, and that gets A by itself. This next step is done in my calculator. My calculator is programmed with a decimal equivalent of sine 55, and so I can punch this into my calculator pretty much like it looks and evaluate A. Make sure that your calculator is working yet again, but that should be the length of the side that we're looking for here, that side A. Let's do another one. So we're going to label the triangle. I always think the hypotenuse is probably the easiest one to label. And again, it's relative to this angle that we care about here. I'm going to choose my trig ratio. This one I'm going to use the cosine function being adjacent over hypotenuse because those are the pieces of information that I have or care about. Then I'm going to sub in what I know. It's not just cos of an angle, but it's cos of not that, it's cos of 25. And so in this one, I'd write in 25, and the adjacent is a, that's my unknown, and the hypotenuse is 13. Solving for a would equal cosine 25 times 13. And my calculator can evaluate that for me. And so punching it into the calculator, I get 11.8 centimeters. In these ones, I've kind of gone with a arbitrary rule here. We're going to round to the nearest tenth. You might want to keep those equations handy. I'm going to flip the page and they're going to disappear, but those are the equations that I use, those trig equations, in order to kind of solve these triangles. And they're key after I label it in making a choice of how I'm going to get to an answer. So for B, moving through this one, this is the angle that I care about. This would be adjacent to that angle. This one would be opposite. When I have the opposite and the adjacent, that pushes me into the tan equation. And then I'm going to sub in what I know. So it's not just tangent theta, it's tangent 30 is A over 15.5. And again, solving for A would be tan 30 times 15.5. And your calculator can evaluate that. You should get 8.9 centimeters. A few more. Label it, choose the equation, write it down. Then you're going to sub in everything you know about that triangle, and then solve for the unknown. We're going to keep moving on with these, always labeling, choosing the ratio, whoops, wrote it backwards, subbing in what I know, and then solving for my unknown. Something is going to switch in this example. So this one's going to be just a little different, but we're going to go about it in the same way. If you get through F to that stage, you're going to notice that something is different about this. When we were looking at those other ones here, we had our unknown at the top, and everyone up till now has had that unknown at the top, where you just cross multiplied and carried on. F is different because the A, the unknown, is in the denominator. And so there's a couple steps that we need to clear that. So if we wanted to, we could clear the denominator by multiplying both sides by a, and I'm just going to show all my work over here, and then I'm going to show you a shortcut. So tan 60 times a, and the other side, multiplying it all by a, would cancel the a out. And then getting a by itself, then I'd have to divide both sides by tan 60 if you're following along. So making it look better, A would equal, because those would go away, A would equal 15.6 divided by tan 60. So that is the way to think this through. I tend to give students a bit of a shortcut in this and advise you that in these ones, what you can think about is swap and divide. because that's where you're going to end up. You can take a look over here. That's what's happened. We've swapped and divided. And so using this instead, whoops, not highlighting, instead of, showing all my algebra work, I'm going to simply write that A equals 15.6 divided by tan 60. And that has shown my work for this swap and divide. And it's also got me ready so that I can put this into my calculator. So this one's a little different, right? The calculator will still work the same, and it should come out to 9.0 centimeters. So these two are really good examples to have up here because they do show how things can be different when the unknown is in the top and when the unknown is in the bottom. It's slightly different in the algebra to get to the answer. So those are things to kind of keep straight in your mind. It might be worth noting in your notes so you could look back to them. We're going to carry on with the last two on this page, and then we're going to move to the solving for an angle. They're all going to be the same. We might see now an unknown in the denominator. So I've labeled my triangle. I'm going to write out my equation. I'm going to sub in what I know. And again, we can see that that unknown is in the denominator. So this is where I'm going to remember that I swap and divide. Or you could show all your work like I had up there in red. And on my calculator, I could evaluate side A to be 13.9 centimeters. One last, I label it, I pick my equation, I write it down. Sometimes I start to skip writing that step. I'm going to sub in what I know. There we go. And I'm going to solve for A. In this case, it's down below. So this is that swap and divide reality. That's a 91 on the top. So in my calculator, A, I could evaluate to be 95.2 centimeters. So we've been using the trig ratios to solve for a side. Up next in the notes is using trig ratios to solve for an angle. So to solve for an angle, we're going to follow pretty similar steps. We're going to label the triangle. We're going to therefore decide on which trig ratio is relevant. We're going to sub in what we know. And down here, the solving is a little different. But if you remember, on the last page there, we had two different realities. There's only one reality when we deal with the angle measurements. The one thing about solving for an angle, this is when you had to use the inverse trig function or the second function button, right? That's what pops out the angle. So solve for angle. So hopefully we've got our calculator squared away. In these ones, we're supposed to be solving for angle G down here. So I would label this triangle up, pick my trig ratio, sub in what I know. In this case, it's G instead of theta, because that's where the angle goes. And here you can see we have to be able to do this in our calculator. So in my calculator, I punch 3 divided by 7 second function cos, but I'm pretty sure there's a lot of different calculators out there. Hopefully you remember this from earlier in the notes here. So you can solve for angle G and round it to the nearest degree, it says. So 65 degrees. Solving for angle D here, labeling my triangle is always the first step. Choosing my trig ratio is always next. Subbing in what I know, in this case it's angle D, and my opposite is 3, and my adjacent is 4. And then really it's just calculator work, popping that angle measurement out and rounding to the nearest degree. Label, choose the function, sub in what you know, and then solve for what you're looking for. There's 4 more on the other page. I'll throw my work up quickly because sometimes that's where things go wrong, and that's frustrating for students and you can't figure out what you did wrong. Usually it's the labeling of a triangle. Now that I've said that, I'll probably make a mistake here. In this one, I'm going to choose the function, but I'm not going to write out the whole equation. So this might be something that you're skipping. If you're not comfortable with that yet, then go ahead, write out the equation and then do the work on your calculator. And the last one, asking you to solve for a question mark. And then using your calculator to solve for that missing angle. So that gives you some of the skills. The next video I'm going to make is the second part of part 2, where we put it all together and solve triangles.